Hey everyone, in this video I will be going over the graphing by hand method for solving systems of linear equations. So when solving a system of linear equations, there are a variety of methods we could use. The first method we will discuss is the graphing by hand method. Okay, so this method will require some prior knowledge here where we will need to remember how to graph lines. Okay, and that means lines in any form. So slope-intercept form, which is y equals mx plus b, standard form, or point-slope form. So let's take a look at this example problem. So I've got two lines here. I've got y equals 1 over 3x plus 3 and y equals 4x minus 8. Well, these are in the form y equals mx plus b, so these are in slope-intercept form. And we like slope-intercept form because we don't need to manipulate these equations in any way. We don't need to do any algebra in order to graph them. They're already set up in a way that we can look at the information that's provided and immediately start graphing them. Okay, so let's color code these lines here. So this top line we will do in red. The bottom line we will do in blue. So now we're going to graph these lines. So taking a look at the top one, our red line, y equals 1 over 3x plus 3. I'm always going to start with the y-intercept. So my y-intercept is going to be this last number here, our b term. And because it is plus 3, I'm going to go to my y-axis. Okay, it's labeled with the y here. And I'm going to go up to positive 3 and make my first point. From there, I'm going to take a look at my slope, or my rise over my run. That will be the number attached to the x. My rise is going to be 1, and my run is going to be 3. And because 1 over 3 is a positive number, there's no negative sign out in front, I know my rise will be going up, and my run, 3, will be going to the right. It will be sloping up from left to right. So from my slope, I'll go up 1 for my rise, and to the right 3 for my run. Make my next point. Okay, and then I can continue this as far as I would like. I could also extend it in the opposite direction. Because it is a line, it will go on forever. Okay, so now I will take a look at my blue line. My y-intercept, again, is my b term, the number that's attached on the back end here. It is minus 8, so that means I'm going to start at negative 8. This sign does matter. So I'll go to my y-axis, and the y-intercept is negative 8. So I'll make my first point at negative 8. Now if I take a look at my slope, it is the number attached to the x, but I'm always looking for a fraction. So here I don't quite have a fraction, so I don't have a rise over a run. So what I'm going to do is, because this is a whole number, I'm going to make my own run. I'll put 4 over 1, because 4 over 1 is the same thing as just having 4. So this means I'm going to, from my negative 8, I'm going to go up 4 and to the right 1. It is a positive number. 4 is a positive number, so I'll be going, this line will be going up from left to right. We'll go up 4 to the right 1. Up 4 to the right 1. So now what I'm going to do, I'm going to make some lines here. Here's my red line. Here's my blue line. Make sure you are always using a straight edge when you are graphing the lines. Very helpful. And because they are lines, I'm going to attach some arrows to both of them. Okay, so I have graphed both my lines. But what am I looking for exactly? Okay, so I graphed both lines, but I really haven't presented a solution or a clear solution. So what point here do we care about? Okay, we care about the point where they intersect. And for those of you that don't have the thesaurus handy, intersect just means cross. Okay, and this point where they cross is called the solution of a system of linear equations. Okay, so if I take a look at where these two lines cross, it looks like I go over 3 on the x and up 4 on the y. Therefore, the solution to this system of linear equations is going to be the point 3, 4. Okay, so I have a little note here. Graphing linear equations is easiest when the lines are in slope-intercept, or y equals mx plus b form, such as that last example. If you are given an equation or equations in standard form, point-slope form, or no form at all, I suggest converting the given equation or equation into slope-intercept form. So that'll come in handy for this next example. So we're going to take a look at some special cases. Okay, we'll figure out exactly why they are special in just a couple minutes. So I've got my system here. X minus 9y equals negative 72, and x minus 9y equals negative 9. So I'm going to color code these again. Top one will be red. Bottom one will be blue. And because up above I said it is easiest to graph lines when they are in slope-intercept form, there could be different ways of graphing these lines, but I always like to put them in slope-intercept form. So I'm going to have to do a little bit of algebra here. So off to the side here, I'll rewrite the equations so I can set them up into slope-intercept form, because currently they are in ax plus by equals c form, or ax minus by equals c. Both of those are in standard form. When the x and y are on the same side of the equal sign, that means they are in standard form. And as I said, you could have different methods of graphing lines depending on which form they are in. But I've always tried to put them into slope-intercept form before I graph them. Okay, so taking a look at the first one, or no, let's do the blue one first. I'll rewrite it, x minus 9y equals negative 9. So to get it in slope-intercept form, I need to isolate the y, or get the y all by itself. So to do that, I'll subtract x. X minus x is going to cancel out. So on the left side, I'm left with negative 9y. my equal sign. And on the right side, I'm going to rewrite this as negative x minus 9. Okay, we're almost there. So on the left side, I've got negative 9y. This is the same thing as negative 9 times y because they're touching. There's no symbol in between. So opposite of multiplication is going to be division. So I will divide all terms by negative 9. When I do that, these negative 9s are going to cancel, so I have my y isolated, equals. This fraction right here is the same thing as having negative 1x divided by negative 9. So I'll take a look at my numbers here. So negative 1 divided by negative 9. Negative signs are going to cancel out, so I'm left with 1 over 9x. And negative 9 divided by negative 9 is going to be a positive 1. So now it is in slope-intercept form because the y is isolated. I've got y equals mx plus b. So I'm just going to put a little star next to this so I know this is the equation that I need to graph. So now I will switch colors and I'll take a look at my red equation. I will rewrite it. X minus 9y equals negative 72. Same thing, I'm just going to try to isolate that y, get it all by itself. So my first step in doing that will be to subtract the x. X minus x is going to cancel out. I'm left with negative 9y equals, I'll rearrange these two, negative x minus 72. Similar to the blue equation, negative 9 and y are being multiplied. They're touching. There's no symbol in between. So opposite of multiplication is going to be division. So I will divide everything by negative 9. Negative 9 divided by negative 9 is going to cancel. So my y is therefore isolated. Negative x, or negative 1x divided by negative 9. Negative signs are going to cancel out, so I have 1 over 9 x, and negative 72 divided by negative 9 is going to be a positive 8. So I'm left with y equals 1 over 9x plus 8. This is also in slope-intercept form, or y equals mx plus b form. So I'm going to put a star next to it because this is going to be the equation I'm going to graph. So because my marker is red right now, we might as well graph the red equation. So it's important to note here that I started with a standard form equation and just converted both of them into slope-intercept form. I didn't change these in any way. I just manipulated them. So if you have a specific method for graphing lines that are in standard form, if you're doing it correctly, it should come out the same as my slope-intercept form equations here. They are the same lines, okay? Just manipulated in a different way into a different form. So for my red line, I will start at my y-intercept, which is positive 8. So I go up to plus 8. And my slope, or my rise over run, is going to be a rise of 1 and a run of 9. So because 1 over 9 is a positive number, I know this line will be sloping up from left to right. So I will go up 1 to the right 9. And just for continuity's sake, I can also go down 1 into the left 9. Okay, now let's find the important points for my blue line. My y-intercept here is positive 1, so I'll go up to plus 1. And my slope is the same as my red equation. It is 1 over 9, positive 1 over 9. So I know my rise is 1 and my run is 9. It's a positive number, so it will also be sloping up from left to right. So I'll go up 1 to the right 9. Down 1 to the left 9. Create a couple nice lines here. some arrows because they are lines. They will continue forever. Even though our grids are only 10 by 10, these will go to infinity and beyond. Okay, so as we saw with our first example, we're trying to look for the point where these two lines cross. Okay, and taking a look at these two lines, looks like they're not going to cross. Okay, so what is the solution to this system of linear equations? Switch my color here. It's actually going to be no solution. Okay, I'm going to scroll down a little bit so I can finish the page. Okay, and why is our answer no solution? It is because these lines will never intersect. Okay, they will never cross. Doesn't matter if we're on that 10 by 10 grid or if we go up into the hundreds, the thousands, or even the millions. They will never cross. Okay? And when lines never intersect, will it always be the case that there will be no solution? Okay? And when two lines have the same slope, they will never intersect. Okay, and as we saw with that last example, when we converted them from standard form into slope-intercept form, the slope for both equations was 1 over 9. So because they were both 1 over 9, we knew that they had similar slopes. They were never going to cross no matter where we were on the coordinate plane. Okay, so what does that mean, no solution? This means that there's no ordered pair that will make this system of equations true. Because that's the whole goal of this. We're trying to find one answer or one point that makes both of those equations true simultaneously. So there is no ordered pair that will do that for those equations. Okay, we'll take a look at one more special case and then we'll head on to the example problems. So if I take a look at this system of linear equations right here, I've got 21x plus 3y equals 6, and y equals negative 7x plus 2. So I know one of these is in standard form and one of these is in slope-intercept form. So I will only have to change one of them. So I'll make my top equation my red line, my bottom equation my blue line. So if I take a look at my blue line, it's in y equals mx plus b, or slope-intercept form currently. So I'm not going to need to change this. I'm going to put a star next to it because that one's ready to go. It's ready to be graphed. But I will need to take care of this top equation because it's in standard form. And how do I know that? The x and the y are on the same side. So I will rewrite it. My first step is going to be to move this x over to the other side because I'm trying to isolate the y. So I will subtract 21x. (21x minus 21x), it's going to cancel. So I'll have 3y equals I'll rearrange these two, so negative 21x. I always like to put my x first. And then I've got a positive 6 here, so I'll put plus 6. Okay, so I have 3y. There's no symbol in between, which means they're being multiplied. So opposite of multiplication is going to be division, so I will divide every term by 3. 3's on the left side are going to cancel, so therefore my y is isolated. Negative 21x divided by 3 is going to be negative 7x. And positive 6 divided by 3 is going to be a positive 2. So this is now in slope-intercept form. So let's graph these lines. Because I have my red pen, I will start with this red line. So y-intercept is going to be this last number here. It's plus 2. So on the y-axis, I'll go to positive 2, make my first point. Looking at my slope, which is the number that's touching or attached to the x, I've got negative 7. That's not a fraction, but I can easily make it a fraction by putting it over 1, because negative 7 over 1 is the same thing as negative 7. So because my rise is negative 7, that doesn't mean I'm actually rising. I'm actually going to fall because it's negative. So I'm going to go down 7, 1, 2, 3, 4, 5, 6, 7, and to the right 1. Okay, this is a negative number, so I know it will be sloping down from left to right. Okay, I'm going to run out of room if I go down 7 here. That's not possible. I can only go down 5 on this coordinate plane. So on the other side, I will go up 7, 1, 2, 3, 4, 5, 6, 7, and to the left 1. For my blue equation, I've got y equals negative 7x plus 2. So I'll start at my y-intercept, which is 2. And same thing, my slope is negative 7, so I can write that as negative 7 over 1. So I can go down 7 to the right 1, or I can go up 7 to the left 1. So what I'll do is I'll connect all these points. Draw some arrows, because it goes on forever. So let's take a look at this here. It turns out that these two lines were actually the same line, just written in different forms. So as we said, the first one was in standard form. The second one, our blue line, was in slope-intercept form. Turns out they are the exact same line. So what is the solution to this system of linear equations? It will be infinitely many solutions. I'm going to go down just so I can explain this a little bit further, running out of space. So why is it infinitely many solutions? And that is because these lines intersect at every point. All right? They are the same line, as we just discussed. Okay, and will this always be the case if we have two lines, it appears that they overlap each other, will our solution always be infinitely many solutions? The answer is yes. When two lines are identical, they will intersect each other at every point they touch. Okay, so looking at the above example, the infinitely many solutions means that regardless of what ordered pair we plug into both of the systems, okay, it will make both of those equations true because they are the same equation. So all ordered pairs will satisfy both equations simultaneously. So down here, I have a little cheat sheet for you. This could be useful. Systems of linear equations will always have one solution, no solutions, or infinitely many solutions. Okay? There is no such thing as having two solutions, for example, or let's say 8 solutions, because you can't have two lines that are going to cross in two different places. Okay? If there is a line that is intersected by something in two or more different places, it turns out that that second function is not a function, or it doesn't have to be a function, okay? Or it's certainly not a line. So, little shortcut here, you can determine how many solutions a linear system has by looking at the slopes of the two given lines. So we know it has one solution if the lines have different slopes. We know the system's going to have no solutions if the lines have the same slope, and that's the second example we took a look at. And we know the system will have infinitely many solutions if the lines have the same slope and y-intercept, which ultimately means that they are the same exact line. Okay, looks like it is example time. So I'm going to zoom in just a little bit. Okay, in our instructions, solve each linear system of equations by graphing. So let's identify these two lines. Top one is going to be my red line. Bottom line is going to be my blue line. Okay, in quick analysis of these two equations, y is isolated, and it is in the form y equals mx plus b, so we don't need to do anything to either of these equations. We can just go ahead and graph them. All right, they are in slope-intercept form. They are ready. So starting with my top one here, or my red equation, y-intercept is going to be -4, so I'll go to -4 on the y-axis. My slope is -2/5, or -2/5. So from this point, I'm going to go down 2 and to the right 5. Down 2 to the right 5. Or I could go up 2 and to the left 5. So there I have the important points for my red line. Now time for my blue line. Y-intercept is +3, so +3. And slope is -9/5, or -9/5. So I will go down 9, 1, 2, 4, 5, 6, 7, 8, 9, and to the right 5. Both of these lines have negative slopes, so that means they are both going down from left to right. Okay, so now I will connect these. Start with my blue line. Put some arrows on it to show that they are indeed lines. Now for my red line. Attach some arrows to it as well. Okay, so I am looking for the point where they intersect, so that would be right down here. So if I'm going to write that as an ordered pair, the ordered pair that is going to make this system of equations true is going to be to the right 5 on the x, so over 5, and down 6. Okay, so I went over 5, down 6. Okay, now I'll move on to the next example. Okay, I have for my first line y equals 8, and my second line y equals negative 15 over 4x minus 7. So my top line is going to be red. My bottom line is going to be blue. Okay, taking a look at both of these equations, it looks like the y is isolated in both of them. They're in y equals mx plus b form. So we don't need to do any algebra or manipulate these in any way before we graph them. So taking a look at y equals 8, I've got no x on the right side, so that means it's going to be a horizontal line. Whenever I have y equals a number, that means regardless of what my x-coordinate is, my y-coordinate will always be 8. So I can go up to 8 on the y-axis, okay, and I have no slope. So that means if I plug in 0 for x, which I have no x, I know I'm going to get 8. If I plug in 10 for x, I'm still just going to be left with 8. I could also plug in negative 10. I'm going to be left with 8. It's just a horizontal line. And that will always be the case. But be careful. If it were x equals some number, then it would be a vertical line. But because it's y equals 8 or y equals any number, it's going to be a horizontal line. So now I'll take a look at my bottom equation. So my y-intercept is negative 7, so I'll start at negative 7 on the y-axis. And from there, I've got negative 15 over 4 as my slope, so I can go down 15 into the right 4. It's a negative slope, so it will be sloping down from left to right. Or I could go up 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, into the left 4, 1, 2, 3, 4. So I will graph these two lines. Start with my red one. Now I will do my blue one. Add some arrows, which are always important. These are lines, not line segments. So now let's take a look at the point where they cross. Looks like right here, so that is to the left 4. So it's going to be negative 4. And up 8. Okay? So the point that satisfies both of these equations is going to be the point negative 4, 8. On to the next example. Okay, we have y equals 3x minus 6. That's going to be my red line. And y equals 3x plus 4. I'll make that my blue line. They are both in slope-intercept form because the y is by itself. And I can read it off as y equals mx plus b. So I can just start graphing these. So for my red line, my y-intercept is negative 6. So I'll go down to negative 6. And my slope is going to be 3, which is the same thing as 3 over 1. So I can go up 3 into the right 1. Okay, and I can extend that as far as the coordinate plane will allow me to. Could also go in the opposite direction, down 3 to the left 1. Now for my blue line, looks awfully similar as if it has the same slope as my red line, but a different y-intercept. So my y-intercept for my blue line is going to be positive 4. And slope, same thing. It's the same thing as 3 over 1, so I can go up 3 to the right 1. Up 3 to the right 1. Or I could extend it in the opposite direction. If I create these two lines, there. Now I will put my arrows here to show that these two lines go on infinitely. So I'm looking for the point where these two lines are going to intersect. Okay, and they have the same slope, which means they never will intersect. Therefore, my solution here is going to be no solution, because these two lines are never going to cross. On to the standard form examples. Almost done, only 3 more. And these ones are going to require a little bit of algebra just because they are not in slope-intercept form. So my top line will be in red. My bottom line will be blue. So I'm going to draw arrows over here so I've got a little space to do some work. Okay, not the straightest arrows you've ever seen, but bear with me. So for my blue line, because my pen is blue right now, I might as well do that one. I'll rewrite the equation. So I've got 4x minus y equals 7. My goal is to get the y isolated or all by itself, so I will subtract 4x on both sides. (4x minus 4x cancels. So on the left side I've got negative y equals, I'll rearrange these, negative 4x plus 7. Okay, y is almost isolated. Some people will leave this as is. That is not correct. Okay, this is the same thing as having a negative 1 in front of this y. So let's divide everything by negative 1 to get rid of that negative sign. When we do that, those are going to cancel, so I'm left with a positive y. That's a very good thing. Negative 4 divided by negative 1 is going to be a positive 4x. And positive 7 divided by negative 1 is going to be a negative 7. Okay, this is now in slope-intercept form, so I'll put a star next to it so I know to graph it later. And for my red line, I will rewrite it. I've got 3x plus y equals 7. My goal is to get that y by itself, so first step will be to subtract 3x on both sides. (3x minus 3x is going to cancel, so on the left side I have a y equals, and if I rearrange these I've got negative 3x plus 7. That is now in slope-intercept form, so I'll put a star next to it so I know to graph it. Thankfully, my attention isn't that short term, so I will go ahead and graph it right now. So my y-intercept for my red line is going to be positive 7, so I'll go up to plus 7. And my slope is going to be negative 3. That's the same thing as negative 3 over 1. So because it's a negative number, I know it's going to be sloping down from left to right, so I will go down 3 to the right 1. Down 3 to the right 1. And I will continue that as far as the coordinate plane allows me to go. And I can also extend it in the opposite direction. Now time for my blue line. Okay, y-intercept is going to be -7, so I'll start at -7. And from there, my slope is just 4. It's the same thing as 4 over 1, so I can go up 4, 1, 2, 3, 4, and to the right 1. Up 4 to the right 1. Okay, now that I have all the important points, it's time to make my line. So I'll start with my red line. And my blue line. Don't forget to add arrows. Okay, and as I always do with graphing systems of linear equations, I'm looking for the point where they cross. So that looks like it is over 2, up 1. And there we go. On to the next one. Okay, for this one here, I've got x equals 5. I'll make that my red line. And 4x plus 5y equals -15. That will be my blue line. For my red line, looks like I'm all set. There's nothing I can really do to this. Even though it is in standard form, there's nothing I can do to this to manipulate it any further. It's almost as if it is lacking information, even though it technically isn't. As I discussed with one of our examples above, I believe it was the second one, if I've got y equals a number, that means I'm going to have a horizontal line going through that number. If I've got x equals a number, that means I'm going to have a vertical line going through that number. Okay? Because my number is 5, that means regardless of what my y-coordinate is, so it could be 10, my y-coordinate's 10, doesn't matter, I'm still going to go over 5 on the x. Or I could go to -10, I'm going to go over 5. You could also go to -4 if you wanted, it's still going to be 5. Okay. Now for my blue line, I'm going to have to do a little bit of algebra here. So I will rewrite the equation. 4x plus 5y equals -15. I want to get the y all by itself. So first step is going to be to move over this x. So I will subtract 4x on both sides. X's cancel. So I'm left with 5y on the left side equals -4x minus 15. I will divide everything by 5. So when I do that, these 5's cancel, and I get y equals -4 over 5x, and -15 divided by +5 is going to be -3. So I'll put a star next to this because it is now in slope-intercept form. I can graph it. So I'm going to start at my y-intercept, which is -3. And from there, my slope is -4 over 5. It's a negative number, so I know it's going to be sloping down from left to right. So I will go down 4, 1, 2, 3, 4, and to the right 5. 1, 2, 3, 4, 5. I could also go up 4 if I wanted to extend it in the other direction. 1, 2, 3, 4, 5. Oh, sorry. 1, 2, 3, 4. And to the left 5. There we go. I'll create my lines now. slap some arrows on it. And same goes for my red line. So where do these two lines cross? It looks like we go over 5 on the x, and we go down 7 on the y. So the solution to the system of linear equations is going to be the point 5, negative 7. One more example. Thanks for sticking around. I know it's been a long video. But sometimes you got to do what you got to do, am I right? So, top equation. I'll make that my red line. I'm not going to switch up the order now. Bottom equation will be my blue line. They are both in standard form, and I know that because the x and y in both equations are on the same side of the equal sign. So that means I'm going to have to do some algebra, unless you have a more efficient method of doing this. And that is perfectly okay if you do. Okay, so I'll start with my blue line. I'll rewrite it. 6x minus 3y equals 12. I need to get the y by itself, so I will subtract 6x on both sides. Once I do that, 6x minus 6x cancels. I'm left with negative 3y on the left side equals negative 6x minus 12. Or, sorry, plus 12. It's a positive 12 here, so it's going to be plus 12. My mistake. I'll divide everything by negative 3. Negative 3's on the left side are going to cancel, so therefore I have my y isolated. Negative 6x divided by negative 3 is going to be a positive 2x. And positive 12 divided by negative 3 is going to be a negative 4. And I'll star this because it is now in slope-intercept form. It is ready to go. Now my red line. I will rewrite it up here. So I've got 2x minus y equals 4. I will subtract 2x on both sides. When I do that, 2x minus 2x is going to cancel. So I'm left with negative y on the left side equals negative 2x plus 4 on the right side. This y is not yet isolated, even though it appears it has no number attached to it. It has a negative 1 attached to it, so we need to divide everything by negative 1 to get rid of that negative sign. When we do that, negative signs over here are going to cancel, so I'm left with y equals negative 2x divided by negative 1 is going to be a positive 2x, and 4 divided by negative 1 is going to be negative 4. It is now in slope-intercept form, so it's good to graph. So because my pen is red right now, I'll go ahead and graph this red line. So I'll start at my y-intercept, which is negative 4. And from there, I'll take a look at my slope, which is 2, aka 2 over 1. So I will go up 2 to the right 1. Or I could go down 2 and to the left 1. And for my blue line, I'll start at my y-intercept, which is negative 4. And my slope is 2, which is the same thing as 2 over 1. So it turns out that these two lines, even though they were written in the same form, they're actually the same exact line. One was just a scaled version of the other. So if you take a look here, if you were to multiply this entire top equation by 3, you would actually get this bottom equation. So that was kind of sneaky. two different equations in the same form, but turns out they create the same exact line. One is just a scaled version of the other. So I'll still add arrows. I'll go through the process. So when taking a look at my solution here, it's not going to be an ordered pair. Turns out any ordered pair that I plug into this top equation will also work for this bottom equation. So my solution is going to be infinitely many solutions. And that's it for the graphing by hand method for systems of linear equations. If you have any other questions or would like any more practice, please come see me, and I would be happy to help you out.